Okay, folks, I apologise for the confusion. I am going to work through exercise 5L, question 3. Okay, so I'm going to start from part B. But really quickly, the question is, okay, at 2100 hours, a navigator on a vessel heading south notes the angle of elevation of a lighthouse is 1 degree 20 minutes on a bearing of 340 degrees true. This is the lighthouse marking. All right, I'm going to start at B. Use a protractor to draw the position line from the lighthouse. So as always, I'm going to very lightly in pencil, first of all, mark in my cross because it helps me be a little bit more accurate when measuring my angles. So it's looking at it on a bearing of 340 degrees true. So I'm going to slide mine down so I don't go off the page. Remember I taught you that little trick a while ago. Okay. And then I'm going to get my ruler. So 340 degrees true is here from the lighthouse. However, remember the boat is out in the ocean, so I extend my line. Okay, that is part B. Part C says calculate the distance from the lighthouse. So I want to find the distance I've gone along this line somewhere. So what I'm going to do is I'm going to use some 2D knowledge to calculate this distance. So this is where my right angled triangle comes in. I know my lighthouse, I've been told, is 120 metres. And I see it at an angle of elevation of 1 degree 20 minutes. Okay, and I need to find this. So I've been given the opposite and I need the adjacent. As always, we write our rule, we substitute, we solve. So tan 1 degree 20 minutes equals 120 over D. We do our sneaky switch because the D is on the bottom. So D equals 120 over tan 1 degree 20 minutes. So I'm going to round that up to 5156 metres. It's also good to write in nautical miles. Which equals 2.78 nautical miles. Okay. So where that calculates the distance. Whoops, there you go. So I've gone 2.78 nautical miles. Part D then says fix the vessel's position at 2100 hours. So this is where the scale comes into play now. I've gone 2.8 nautical miles. Okay, so 1.2468 is about 3.2 centimetres. So I've gone 3.2 centimetres. 1, 2. Okay, and that is where the boat is at 2100 hours. Okay, so the next one says, if the vessel is moving at 10 knots, plot its expected position at 2130. So the first thing I'm going to put in is I know that that boat was travelling south. So if you read earlier on in the question, you'll see that it was travelling in a southerly direction. So at 2130, okay, let's get my paper. So I've gone 10 knots in 30 minutes. Distance equals speed times time. Distance equals 10 times, we write it as an hour. Distance equals 5 nautical miles. So I've gone 5 nautical miles in that time. I go back to my trusty scale. 5 nautical miles is approximately about 5.5 centimetres. So I've gone an extra 5.5 centimetres, which gets me to this point here. Okay, and this is where I am now. Final question, how far is the vessel from the lighthouse at 2130? All I need to do is draw a line that connects these 2 points. Whoopsie. Connect the 2 points, and once again, I'm going to measure. Okay, so I've got about 8.4. So 8.4 is here. So I've gone, oh, I don't think that's right. Hang on, 8.4, I can't measure, ignore me. Let's say 8.4 is actually about here. Sorry. So I've gone 1, 2, 3, 4, 5, 6, 7.24. I've gone about 7.6 nautical miles. Okay? And that is how we do question 3. Okay, I'll quickly mark this in. Yeah, that was 5 nautical miles. All right, good luck.